Hi, good afternoon, Dr. Senior. Myself, Dr. C. Anand, Professor, Computer Science and Engineering, Anda College of Technology, Erode. Here we discuss what Boolean algebra. Okay, Boolean algebra is a branch of mathematical that deals with operations on logical values with the binary variables. The Boolean variables are represented as binary numbers to represent truths, that is 1 equal to 2 and 0 equal to false. Mainly it is used for analyze and simplify the digital logical circuits. Therefore, it supports for the entire digital logic circuits. It is easy to analyze the circuits and design. It is used only the binary numbers, that is 0 and 1. It is also called as a binary algebra or logical algebra. What are rules in Boolean algebra? It can be used only two values, that is binary 1 for high and binary 0 for low. Complement of the variable is represented by an overbar for the any variables. For example, the complement of the variable b is represented as thus if b equal to 0 then equal to 1 and b equal to 1 then equal to 0. Next, ORing concept, that is a plus sign, a plus b plus c for variables. For example, ORing of a b c is represented by the a plus b plus c. Next, logical ANDing operations. The two or more variables represented by writing a dot between them, such as a dot b dot c. Sometimes the dot may be omitted like a b c. Next, what are the applications of Boolean algebra? It is used to perform the logical operations in digital computers. In digital computers, true represented by 1, that is a high volt, and false represented by 0, that is a low volt. Logical operation performed by logical operation, that is a AND, that is conjunction or disjunctions. That is, the next one is a NOT, that is a negation or complement of the application of Boolean algebra. Next, how we are going to implement the Boolean algebra? It is mainly implemented for the computer electronic circuits. These circuits perform Boolean operations and these are called as logic circuits or logic gates. Next is logic. What do you mean by logical gates? It is a basic building blocks of any digital systems. It is an electronic circuits having one or more than one input and only one output. Okay. Therefore, mainly it is an electronic circuits having one or more than one input and only one output. The relationship between the input and the output is based on the certain logic. Based on this logic gates are named as an AND gate, OR gate and NOT gate. Totally there are 7 gates are available: AND, OR, NOT, XOR, NAND, NOR and XNOR gate is available. First one is the logic gates. First one is the AND gate. A circuit which performs an AND operation is shown in figure. Here A and B are the input, Y is the output. It has n input, that is n less than or equal to 2 and 1 output. Here truth table is inputs and output. Here A and B are the input, output is AB. All of you previously discussed about A dot B or AB, that is the ungated solutions. Okay, what is the truth table is for input A both are input is 0, output is 1. 0 and input and output is 0. Then 1 and 0 input, output is 0. Then both inputs are 1, finally output is 1. Remaining all inputs are same. Next, OR gate. A circuit which performs an OR operation is shown in the figure. It has n input and 1 output. Here show the logic diagram of OR gate. Your truth table is A plus B. That is A equal to A0, B0 output is 0. A equal to 0, B equal to 1. What is the output is 1. Then A equal to 1, B equal to 0, output is 1. Then both inputs are 1, output will be the 1. This is the OR gate. Next, NOT gate. It is also known as the inverter. It has one input A and one input is output Y. Therefore, complement of the input, that is A equal to 0, now output is 1. B equal to that is A equal to 1, output is 0. There is a complement of the input. Next, NAND gate. That is a NOT AND operation is a combination of NAND gate. Okay, it has n input and 1 output. Logic diagram is first AND gate. Next one is OR gate, the NOT gate. There is a complement of the input. That is input is A and B, output is AB bar. Okay, input is A and B are 0, output is 1. That is input A 0, B equal to 1, output is 1. Then input A equal to 1, B equal to 0, output will be the 1. both inputs are 1, output will be the 0. That is a first, you have to perform first AND gate operation, NOT gate operation. Finally, it shows the output of NAND gate. Next, logic gates. It is a combination of NOT and OR operations known as NOR operations. Yeah, it's also same for the input. N number of inputs, only one outputs. Here is the logic diagram for the first one is OR gate, next one is a NOT gate. This is the logic diagram for the NOR gate. Also same as the output table. Okay, input or outputs truth table. A equal to 0, B equal to 0, output will be the 1. That is the sum of inverters. Next, XOR gate. It is a combination of XOR or XOR. It is a special type of gate, can be used in the half adder, full adder and separator circuits. Okay, the exclusive OR gate is abbreviated as XOR gate, or sometimes called as X-OR gate. It has n number of inputs and one is output. It's a logic diagram for the XOR gate. Here the truth table is both inputs are same, output will be the 0. Different inputs, output will be 1. For example, if A equal to 0, then B equal to 0, output is 0. Okay, then that is similar to that. A equal to 1, B equal to output will be 0. But A input, A is 0, B equal to 1, the output is 1. Similarly, A equal to 1, B equal to 0, the output is 1. That is the concept of XOR gate. Next, XNOR gate. It is a combination of AND operations. Okay, this is the logic gate diagrams. Finally, truth table is A equal to 0, B equal to output is 1, A equal to 0, B equal to output is 0, A equal to 1, B equal to 0, output is 0. Both inputs are 1, output will be the 1. It is a special type of gate. It can be used in the half adder, full adder and separator circuits. Next one is a basic Boolean theorem of algebra. What is the first one is a T1, that is a 0 plus equal to A, 0 into A equal to 0. There is a properties of 0 concept. Next, T2, there is a properties of 1, that is A 1 plus A equal to 1, 1 into A equal to 1. So this is a basic theorem of Boolean algebra. Next one is the commutative law. A plus B equal to B plus A, then AB equal to BA. Third one is the associative law. A plus B plus C equal to A plus B plus C. Similar to that, multiplication AB into C equal to A into BC. Next, distributive law. A into B plus C equal to AB into A. Similar to A plus BC equal to A plus B into A plus C. Then A into A bar B equal to A plus. This is a distributive law. Next is idempotent, that is identity law. A plus C equal to A, then A into A equal to A. Absorption law, that is redundance law. A plus AB equal to A. Similar to A into A plus B equal to A. Next, Boolean algebra, there is a complementary law, that is x plus x bar equal to 1, x into x bar equal to 0. Next, involution, x double bar equal to x. Next, finally, De Morgan's law, x plus y the whole bar equal to x into y dash. Similar to that, x into y bar equal to x bar plus y bar. Okay, first De Morgan's x plus y bar y the whole bar equal to x bar into y bar, x dot y whole bar equal to x bar plus y bar. Next, first one is the De Morgan's law. A plus B the whole bar equal to A bar into B bar. Here the logic diagram of De Morgan's law. First one is the A plus B the whole bar. There is OR gate. The complement of OR gate equal to A bar into B bar. Here show the truth table for the De Morgan's law. Here is the truth table. Okay, A, B. First one is A plus B the whole bar. Similar to that, A bar, B bar, then A dot into B bar. What is the whole bar? Here refers column 3 and column 6. Same inputs, same outputs. So it is called as an De Morgan's law. Next is the De Morgan's theorem 2. A dot B the whole bar equal to A bar plus B bar. Similar to that of logic diagram. Here AND gate, the complement of AND gate is equal to A bar plus B bar. This is the truth table for A dot B the whole bar equal to A bar plus Y. Here column 3, refer the column and 3 and 6, the similar outputs. Okay. That's all about the basic Boolean algebra. Thank you.